here we have a set of data which describes the number of minutes that 22 students spent on a math assignment in a class. So we were asked some questions about this, and I can see right away I'm asked things about like the fastest 25% or the slower 50%. Because we're asked questions like this, it's probably going to be important to find some information about our quartiles. And so the first thing I'd like you to do, and I'm not going to show you this in this video, so if you need help with this, pull up a previous video. But the first thing I want you to do is I want you to get this data typed in your calculator and run the statistics sort of program thing, not really a program, that thing, that one var stats option. Because what we'll get when we see that is we'll be able to find out what all these different quartiles are. The mean, the median, the max, the min, and the Q1, Q3. So I've done that already. I've got my numbers written down from that data. So again, I'm not going to show you that part. So please either pause the video and confirm for yourself that those are in fact the right numbers, or go back and watch a previous video if you're not sure how to find that information. Anyway, once you have those numbers, or if you're just going to trust me that those numbers are right, we can start answering some of these questions. Recall that these are quartiles because basically between each interval here, about 25% of our data is going to occur, or going to fall. So between the median and Q1, we've got 25% of the data. Between Q1 and the median, another 25% of our times are going to fall between there. And so I can see that, I guess that's why they're asking about 25 and 50%. So the first question was the fastest 25% of students took about how many minutes or less to complete the assignment? Well, the fastest 25% are going to occur in this section here. That's, I guess, sort of bottom 25 if you think about it that way. But the fastest 25% of the numbers must be 15 minutes or less to complete that assignment based on our quartile information. Okay, so that's the kind of thing they're looking for on these questions. Next up, they ask you about the slower 50%. So, like, I guess the top 50% if you think about it that way. So the slowest, or the slowest 50% are going to occur right at the median then, because above the median, because remember these are both divided into 25% intervals, about 25% of our intervals, or our data is between these intervals. So altogether from the median, the middle, and up, there's about half our data. So about half our students took 21 minutes or longer to finish this assignment. Okay, and they could ask you questions about 75%. 75% would then obviously involve that third quartile, but 21 minutes or more to complete the assignment for the slower time. Okay, and then lastly, we're asked one more time about outliers. Now I know we had a separate video on outliers, so if you want details about this last step, we can go ahead, or you can go ahead and pull up that old video. But basically, it's going to involve, to find outliers, an interquartile range, the difference between Q1 and Q3. And so if I subtract my Q3 number, 25, from my Q1 number, 15, I get an interquartile range of 10 for this. So about, that's where half my data falls, remember the interquartile range. So then to identify outliers, basically what's going to happen is I'm going to take my lowest quartile, or my Q1 value, 15, and I'm going to subtract 1.5 times that interquartile range. And so if I do this, I end up with 0 again. So basically, if I had any students finish this assignment faster than 0 minutes, there would be an outlier. Obviously, that's not realistic, that's not possible, so we'll ignore that side of the spectrum. The other end then, the outliers on the higher end of the data, would be to take your Q3 value, which was 25 minutes. About 75% of students finished in 25 minutes or less. And I'm going to add 1.5 times the interquartile range. And again, if you watch back a couple of videos, you'll see this in a little more detail. So if I do this calculation, I get 25 plus 15, which gets me a value of 40, meaning if I have any data that occurred after minute 40, that would represent an outlier, an extreme value in this data set. So if I go back and look through my data, do I see any values that are above 40? And I see that, yeah, I do. This student right here that took 65 minutes is definitely going to be an outlier. So I'll just kind of note that 65 minutes represents an outlier. Oops. Get my eye in there. 65 minutes is going to represent an outlier. Not just because we think it's extreme or we think it's very high or very low compared to the rest, but because we have the mathematics to back it up. We're 1.5 times the interquartile range, either above or below my Q1 or Q3 values.